Learning phrase representations using recurrent neural networks encoder-decoder for statistical machine translation. What is RNN? A recurrent neural network is a class of artificial neural networks where connections between nodes form a directed graph along a temporal sequence. It allows it to exhibit temporal dynamic behavior. Actually, this RNN encoder-decoder contains two RNNs in which RNN encodes a sequence of symbols into a fixed vector length vector representation, and it decodes the representation into another sequence of symbols. As we know that in the feed-forward neural networks, there was no sequence, and there was only a one way, that is going from input to the output. There were not numerous hidden units, nothing would be sequential for us. Okay, RNN encoder decoder. What is it? Actually, this RNN encoder decoder is with a hidden unit that is empirically evaluated on the task of translating from English to French. Authors have done this, and they trained the model to learn the translation probability of an English phrase to a corresponding French phrase. The model is then used as a part of standard phrase SMT. What is SMT? Statistical machine translation, by scoring each phrase pair in the phrase table. And improvement can be done by using the conditional probabilities of the phrase pairs computed by RNN decoder and encoder-decoder. This hidden unit is used to improve both the ease of training and memory capacity. There was no way of storing the memory in the feed-forward neural network. That is why RNN is being used. And it jointly trained to maximize the conditional probability of a target sequence given a source sequence. RNN consists of a hidden state H and an output Y, which operates on a variable length sequence. X is equal to x1, x2 to xt. This t is the timestamp, and at each time step t, hidden state is updated. And which function is being used? Function is a non-linear activation function. It can predict the next symbol in a sequence. For example, a multinomial distribution of one of k coding can be output using a softmax function. This equation is clearly showing that h is the hidden state and x is the input. For all the possible symbols, j is equal to 1 to k, where wj are the rows of a weight matrix W. By combining these, we can compute the probabilities of the sequence x. This RNN encoder-decoder is an RNN that reads each symbol of the input sequence X sequentially. And the encoder is an RNN that reads each symbol of an input sequence sequentially. As it reads each symbol, the hidden state of the recurrent neural network changes. After reading the end of the sequence, the hidden state of recurrent neural network is a summary C of the whole input sequence. And the decoder of the proposed model is another RNN which is trained to generate the output sequence by predicting the next symbol yt and given the hidden state ht. As both yt and ht are also conditioned on yt minus 1, and it is being computed by the formula ht is equal to function f ht minus 1 yt minus 1 and c. The conditional probability of the next symbol is also being computed, and there are two components of the proposed recurrent neural network, that the encoder decoder, that are jointly trained to maximize the conditional log likelihood. And log is also being used for log likelihood, that is maximum theta, that is 1 by n, and sigma, in which n is equal to 1 to, that is from 1 to capital N. Okay, hidden layer. How the activation of ith unit, hidden unit, is computed. What do we need to know in this? A novel model architecture is being proposed, and it is simpler to compute and implement. How the activation of the jth hidden unit is computed. First of all, the reset gate Rj is computed. This Rj. Here, sigma, this sign is the logistic sigmoid function, and this dot denotes the ith element of a vector. X, this input, and hidden state are this ht minus 1 is the previous hidden state. And these WR and UR are the weight matrices which are learned. As the update gate ZJ is computed by this formula, and the actual compute activation of the proposed unit HJ is computed by this. In this formulation, when the reset gate is close to 0, the hidden state is forced to ignore the previous hidden state and reset with the current input. An illustration is being shown, and in which the update gate Z selects whether the hidden state is to be updated with the new hidden state. The reset gate R decides whether the previous gate hidden state is ignored or not ignored. And this effectively shows the hidden state to drop any information that is found to be irrelevant later in the future. And it is thus allowing a more compact representation. What is SMT? I was not getting this SMT before. I was like, what is SMT? Because I was not able to connect these two things firstly. This is the machine translation, statistical machine translation. It is the most interesting thing because it would tell us that the translations are generated based on statistical models whose parameters are derived from the analysis of bilingual text corpora. The components are translation model, language model, and the decoder argmax. In the translation model, there are two types of probabilities, translation probability and distortion probability. Basically, this statistical machine translation gives us the probabilities which are based on the statistical models. What is the scoring phrase pairs? Scoring phrase pairs with RNN encoder-decoder. Neural networks have been used to rescore translation hypothesis, to score the translated sentence using a representation of a source sentence as an additional input. When we train the encoder-decoder, we ignore the normalized frequencies of each phrase pair in the original corpora. And this measure was taken in order to reduce the computational expense of randomly selecting phrase pairs from a large phrase table according to the normalized frequencies. And this learning is being shown to ensure that RNN encoder-decoder does not simply learn to rank the phrase pairs according to the number of occurrences. The existing translation probability in the phrase table already reflects the frequencies of the phrase pairs in the original corpus. When a fixed capacity of these RNN encoder-decoder is being used, we tried to ensure that most of the capacity of the model is focused toward the learning linguistic representations. And once this RNN encoder-decoder is being trained, added a new score for each phrase pair to the existing phrase table. What it allows? What would happen on adding these pairs? This allows the new scores to enter into the existing tuning algo with minimal additional overhead in the computation. There are a lot of related approaches being used. Someone was using a feed-forward neural network that has fixed size inputs. And the main lack in the fixed forward neural network was the memory capacity. So there is also they reported an impressive improvement, but their approach still requires the maximum length of the input phrase. And what is being used in this paper? They selected a subset of 418 million words out of more than 2G words for language modeling and a subset of 348 million words out of 850 million words for training the encoder-decoder RNN encoder-decoder. Each set has more than 70,000 words. Oh my god, I was thinking 70,000 words, but they did that. With RNN encoder-decoder, there was a memory capacity and it helped us in searching about these 70,000 words and a single reference translation. For training the neural networks, including the proposed RNN encoder-decoder, it approximately covers 93% of the dataset. All the out-of-vocabulary words were mapped to a special token. For training neural networks, there were a lot of experiments that are being done. The system achieves a BLEU score of 30.64 and 33.3 on the development of test sets. What does these experiments shows on RNN encoder-decoder? Experiment had 1,000 hidden units with the proposed gates at the encoder and the decoder. The input matrix between each input system and the hidden unit is approximated with two lower rank matrices and the output matrix is approximated. All the weight parameters in RNN encoder-decoder were initialized by sampling from an isotropic zero mean Gaussian distribution with its standard deviation fixed to 0.01 except for the recurrent weight parameters. They also use the error delta and the stochastic gradient descent to train the RNN encoder-decoder with hyperparameters. All the weight parameters were initialized by sampling. For the current weight matrices, they sampled from a wide Gaussian distribution and used in the left singular vectors matrix. What is neural language model? The neural language model is being assessed the effectiveness of scoring phrase pairs with a proposed RNN encoder-decoder. And this is a traditional approach. The comparison between the SMT system using CSLM and that using the proposed approach of phrase scoring by RNN encoder-decoder. It is being shown the contributions from the multiple neural networks in different parts of SMT system. They trained CSLM model on 7 grams from the target corpus. Each word was projected into the embedding sequence and to address the computational complexity of using a CSLM in the decoder, a buffer was used to aggregate n grams using the stack search performed by the decoder. And the main reason is only when the buffer is full, a stack is about to pruned. The n-grams are scored by the CSLM. This allows us to perform fast matrix multiplication on GPU. There were quantitative and qualitative analysis as well. In quantitative analysis is being shown the best performance was achieved from CSLM and the phrase scores from RNN encoder-decoder not too correlated. They tried penalizing the number of words that are unknown to the neural networks. I like the words which were not in the shortlist. They added the number of unknown words as an additional feature. The log linear model. They were not able to achieve better performance on the test set, but only on the development set. Qualitative analysis is being shown by the performance improvement comes from the analyze the phrase pair scores computed by RNN encoder-decoder against the corresponding from the translation model. The existing translation model relies on the statistics of the phrase pairs. They expected the RNN encoder-decoder without any frequency information to score the phrase pairs that were based on linguistic regularities. Word and phrase representations. The 2D embedding of the words using the word embedding matrix learned by the RNN encoder-decoder, semantically similar words are clustered with each other. And there is 1000-dimensional vector that generates a continuous space representation. 4 or more words using the bands hut. Phrases are about the duration of the time, while those phrases that are syntactically similar are clustered together. The choices of the target phrases by RNN decoder encoder are closer to actual or literal translations. They prefer short phrases in the general, and many phrase pairs were scored similar by both the translation model and the RNN encoder decoder. It arises from the proposed approach of training RNN encoder on a set of unique phrase pairs, discouraging the RNN encoder decoder from the learning simply the frequencies of the phrase pairs. Further, what they showed that they have generated 50 samples and show the top 5 phrases accordingly to their scores. What they have shown a new neural network architecture RNN encoder-decoder that is able to learn the mapping from a sequence of an arbitrary length to another sequence. Possibly from a different set, they evaluated the proposed model with the task of statistical machine translation for informing about the probabilities that are being computed. A novel hidden unit that includes a reset gate and an update gate that adaptively control how much each hidden unit resembles or forgets while generating a sequence. Thank you.